Hello and welcome to a session on equipments and basic techniques of lighting. In order to fulfill all the roles of lighting designer, a thorough understanding is needed of all the equipment available and the necessary lighting techniques that can be used. The lighting designer can then light actor and the stage using design and illumination in a creative way. It is therefore important to be familiar with the functions and particular merits of each piece of equipment that is likely to be within the experience of the designer concerned. This paper is going to describe the various luminaries that are available for theoretical use, their particular merits, advantages and disadvantages, and how to focus and maintain them. The designer must then exploit this equipment to the full, and this can be achieved only by understanding the basic principles of lighting techniques: front light, back light, down light, up light and silhouette. All these different ways of lighting the actor and the stage are fully explored, as well as the meaning of key and fill light. All this knowledge must be absorbed and put into practice before the designer can become truly expert. Luminaries. The range of lighting and equipment available for the theatre today is enormous and growing larger all the time as new technology introduces new equipment. Just a glimpse at the vast array of luminaries in a professional theatre can be a daunting experience for the uninitiated. However, there are many variations on a theme. It is really not as complex as it first appears. Basically, only 5 types of luminaries are regularly used, and these are the profile spot, the Fresnel spot, the Pebble convex luminaire and the power and the flood. A beam or a projector, which is rather like a modified searchlight, might also be used. The term luminaire merely means any lamp fitted within a casing as opposed to a naked lamp. Within each types of luminaire, up to 4 wattage sizes are available. These normally being 500 watt, 750 watt, 1000 watt and 2000 watt. Choosing the right wattage size is very important, especially to the amateur, for 2 reasons. The first and the most important factor to consider is the number of luminaries that can be used with available main supply. For instance, it is obviously possible to use twice as many 500 watt luminaries than 1000 watt on the same main supply. So, if the large number of lights is required, this might be the better option. Whichever lights are chosen, it is essential to know all the limitations of the electrical supply and to always keep well within them. The second factor to consider is the relationship between the audience and the stage. In a theatre where the audience is seated close to the stage, less light will be needed to reflect off the stage area than when the audiences are farther away. Having considered all the particular requirements of the play, as well as the limitations of the electrical supply and the proximity of the audience, now the attributes of all the different luminaries can be considered. The profile spot, ellipsoidal reflector spotlight. The profile spot provides a hard-edged beam of light. This beam is of a fixed size, is very intense and has minimum flare outside the beam. As a general rule, the narrower the beam angle, the greater the intensity of light produced. This is achieved because the spotlight has a gate aperture placed between the light source and the lens. The maximum amount of light available is collected from the lamp by the reflector and is then passed through the gate. This gate and its built-in shutters determine the profile of the beam. 4 separate shutters are built into the gate to allow shaping of the beam. Some profiles have an extra set of shutters which are mounted away from the gate to provide a soft, out of focus beam. Alternatively, a gobbo can be inserted. This is a special cut out slide or template which creates a pattern of shadows. It is very useful for creating interesting effects such as broken light, dappling through leaves or rippling water. The way light fills a beam can also be altered, and this is called flat, field or peak respectively. Flat field means that the light is spread evenly throughout the beam. Peak means that a larger amount of light is concentrated in the center of the beam. Some profiles are designed to provide a beam of variable size. These luminaries have two lenses which can move independently of each other. One lens is used to vary the size of the beam, the other lens adjusts the focus. Focusing profile. The hard or soft edge of the beam can be focused by the movement of the lens. The beam size can be adjusted when the luminaries is one which provides a variable beam. Vary the beam size with an iris to make it smaller. Shape the beam with shutters to create both hard and soft focus. Use a gobbo for texturing or for projecting an image. The distribution of light across the beam can be altered. This is called peak or flat field adjustment. The Fresnel spot. The Fresnel spot takes its name from the Frenchman who originally designed the lens for use in lighthouses. At first it was mainly used by film studios and was rather expensive. Eventually, however, the price dropped and the Fresnel became more readily available. It is mechanically quite a simple instrument which produces a smooth wash of light. The luminaries provide a soft-edged, ill-defined beam which can be varied in size by moving the lamp and the reflector towards or further away from the lens. The plano side of this lens has its surface cut away in steps to diffuse the light and is therefore called a stepped lens. Unlike the profile spot, this luminary has no gate. The luminaire is simply a box with a Fresnel lens at one end and a lamp and reflector which are both rigidly fixed to a plate. This plate can be made to slide along inside the box. If beam shape is required, a barn door attachment can be fitted to the front of the luminaire. This usually consists of 4 independent doors or leaves and can be rotated and angled to intercept and control the light. These luminaries are ideal for lighting adjacent areas of the stage because the soft edges where the light beams merge. A small amount of flare exists outside the beam, but it is possible to lessen this effect by using a colored lens. This lens has blackened strips which reduce any stray light and eliminate flare. Flare occurs because the light passes through the steps at such a shallow angle, it creates a spectral flare or rainbow, just like the effect of light passing through a prism. Fresnel spots are normally available in 500 watt, 1000 watt and 2000 watt sizes. Focusing the Fresnel. Vary the beam width by moving the lamp and reflector nearer to the lens for a bigger beam angle and further away for a narrower beam angle. Shape the beam of the luminaire with barn doors. It is easier to find the center of the beam if you first close the luminaire door to the smallest beam angle. The Pebble convex luminaire. Pebble convex luminaries work of the same principle as the Fresnel luminaire, but this time the lens is specially designed plano convex lens. The back flat part of the lens is stippled with bumps which diffuses the light passing through the lens and makes the beam semi-hard edged. These luminaries have no flare outside the beam. They are an excellent substitute for profile spotlights. if projection facilities are not required. The barn doors are used to shape the beam. Focusing Pebble convex. Vary the beam size by moving the lamp and reflector nearer to the lens for a larger beam angle and moving them further away for a smaller beam. Shape the beam by using the barn doors. The power. This luminaire provides an intense, virtually parallel, fixed beam of light and is rather like a car headlight. It consists of a lamp which has both a lens and reflector built into it. The luminaire shell is used to support the lamp and to keep the flare to a minimum. Powers are perfect for strong lighting effects such as bright sunlight through windows. Several used together on a batten or a border light can be useful as back or down light. A power can also be an invaluable source of strong key light. The lamps are 1000 watt, available in 3 beam widths, that is 9 into 12, 10 into 14 and 11 into 24 and 500 watts, which are available in 4 beam widths. Powers may also be available with 350 watt lamps. It is necessary only to point the power in the right direction, although because the beam is oval shaped, it may be rotated. The flood reflector floodlight. As the name implies, floodlights are used to cover as large an area as possible to flood the stage with light. They consist simply of lamp with reflector and are supplied with 150, 500 and 1000 watts lamps. By using several of these units together, it becomes possible to light large black cloths or cycloramas. A cyclorama is a curved or straight black cloth hung at the rear to the stage. It may be used as sky or background, painted white and lit as required. There are 3 types of flood lighting. The first provides an even distribution of light. The second type of floodlight provides more light at the bottom of the beam than in any other part. This is achieved by shaping the reflector in a complex way and using an epitaxial lamp, which is very long with a filament that travels along its whole length. These are excellent for lighting back cloths where the luminaries are rigged near to the top of the cloth and when even illumination is needed from top to bottom. The third type of flood lighting is on a batten. Several lamps with reflectors are fixed together in sections to form a strip light. When they are used on the stage floor, they are called ground rows. When used on the front edge of the stage, they are called floats or footlights. When batten are flown, they are known as magazine battens or border lights. Luminaire maintenance. Luminaire is very delicate instruments and should be handled and stored with care. Unless they are maintained in good working order, the reflector and lamp may slip out of alignment and the instrument will not stay in position properly. Nothing is more irritating than trying to focus badly maintained luminaries. Moreover, any old or worn electrical equipment can be potentially dangerous and so, whenever possible, carry out these 3 simple maintenance checks on each luminaire. To avoid an electric shock, always remember to unplug a luminaire before attempting to maintain it. Electrical check. Check cable tails visually for split or breaks. Check the plugs. The colored wires should go to the correct pins and all the terminal screws should be tight. The cable's outer insulation should take the strain in the cable sheath, grip or lamp so that the electrical connections inside the plug are not put under stress. Color coding for Europe. The green or yellow wire is connected to the terminal marked E, that is earth. The brown wire is connected to the terminal marked L, that is live, and the blue wire is connected to the terminal marked N, that is neutral. Color coding for the USA. The black wire is connected to the hot live terminal. The white or neutral grey wire is connected to the neutral terminal, and the green wire is connected to the safety ground, that is earth terminal. Optical check. Clean all the reflectors and the lenses and check that they are correctly positioned. Make sure that the lamp is properly positioned in the lamp holder and trimmed into alignment. Mechanical check. Ensure that all the screws holding the luminaire together are tight. Check that the tilt lock is working correctly. Check that the lens tube and focus knob move freely. Check that the shutters move freely but will remain where positioned. Make sure that the lantern has a safety chain. Every luminaire needs lamp to produce light. There are a bewildering number of lamps available, all with different wattage sizes and lamp bases. Changing lamps. To avoid an electric shock, always unplug the luminaire before changing a lamp. Remove a blown lamp care, as occasionally the glass envelope can shatter. Grasp the lamp by the base or hold it carefully with a soft cloth or a glove. Always ensure the correct replacement lamp is used as specified for the luminaire. Do not forget to wear the plastic glove supplied with the new lamp. Never touch the glass envelopes, as any greasy moisture from your hands will attract heat, and this could melt the glass, resulting in an explosion. If lamps have been touched, it is advisable to clean them with neat alcohol spirit. Do not forget to remove the glove when the lamp is correctly positioned in its lamp holder. Dimmers. Control of the lighting during a performance is a fundamental requirement, and dimmers are the nerve center of any lighting control system. If the play requires a gradual transition from a blackout to full brightness, dimmers provide the means to fade luminaire up and down. The dimmers of today often use an electronic device called an SCR, that is silicon controlled rectifier. This device belongs to the thyristor family of semiconductor devices, which are simply switching device. In order to fully understand the way dimmers work, some basic electrical knowledge is necessary. The electricity supply consists of an alternating current. This means that the supply alternates above positive and below negative 0 volts, making a complete cycle 50 or 60 times every second. 2 SCR are required to control AC alternating current, as current can pass only one way through them. Therefore, the pair of SCRs is wired back to back, one controlling the positive half of the cycle and the other controlling the negative half. With the fader at full, level 10, the AC waveform remains pure. This is because the SCRs are allowing full current to pass through the switching on at the start of each half cycle. But as the fader is brought down, then point at which the SCRs turn on moves further up the half cycle. This is called phase control. Shaping the light. We have seen how to select the light and equipments according to the necessity of the play or the director. Now, let us talk about the shape of the light. Light projected onto a stage inherently has to be some shape. The edges of the beam may be clearly visible or vaguely defined. described as hard or soft. The hardness or softness of the beam depends on the equipment in use and how it is focused to project light. Hard and soft edge beams can be used in ways that an audience will not be expected to notice. A hard edge may be used to trim the edge of beam of a light that would otherwise fall into the audience. For example, on the front edge of a stage. Soft edges may be used to allow the light from one lantern to blend seamlessly with that from another. In these cases, the shapes of the edge of the beam of light becomes merely functional, not seeking to communicate anything to the audience. Where hard and soft edges are made deliberately visible to an audience, often delineating an area or individual on stage, the general point can be made that hard edges are aggressive and soft edges are passive. This is always dependent on the dramatic context. If we could analyze the function of hard and soft edges, one should say that hard edges conveys angst, anger, inner turmoil, etc. And the soft edges are mentioned to be happiness, inner peace, warmth, and so on. The concept of hard and soft as aggressive and passive can be seen to be generally true, but the degree of their effect is extremely relative, because already we had discussed that it depends on the dramatic situation. When we talk about the practicality in it, then profile units use normally shutters to produce hard or soft edges. Other equipment produces only soft edges to the light it produces. However, it should be noticed that the set and lighting designer of the particular scene had to make a choice always to put forth. It is important to understand that as part of our lighting design, we need to manipulate the context of the piece on which we are working to provide us with dramatic emphasis. It is also interesting to note that as a general rule, the human eye and brain are particularly attracted to repeated designs and as with the slated fence that we can imagine. Light can also be projected onto the stage with very specific shapes. Shapes that create precise impressions in the minds of the audience. Any kind of simple words, sign, and we can also create trees, walls, stars, etc. More useful again are softly diffuse shapes that break the light up, adding character to it without limitation of describing anything specific. In this case, the breakup of the light will make a unique contribution to the stage. There are normally only two adjustments that can be made. These utilize either the relationship between the main voltage at dimmer output and the control voltage from the lighting desk, fader at level 10. The relationship between the reduced mains voltage at dimmer output and the control voltage from the lighting desk, fader at level 0. This paper is discussed about the all basic equipments and the instruments of lights. This includes lamps and dimmers, control boards and other systems of lights. The means to exploit this equipment to the full by understanding just how the luminaire's position and angle will alter its effect is also explained. The electrical principles involved in it. Let us summarize what we have discussed so far. All the basic elements and the equipments and the instruments of the light are having great function in the artistic way to explore stage lighting, which includes lamps, luminaries as well as dimmers, control boards and computer system, etc. This technical know-how is supplemented by an analysis of prediction procedure, so it can be seen how the lighting plan for any show can be undertaken in a logical and practical way from the first evaluation of the script through discussion and practical planning to final one. Light can mold the space on the stage with all its architectural characteristics, its color and its own elemental dramatic qualities. It is after all a form of energy, a basic requirement, light and dark, day and night, black and white, a world of contrast. For this, what kind of light can be used and how to select this equipment, especially different theatre lights, these are very important aspects of lighting. The role of lighting designer can never have been detached from these selections of equipments, design and other understanding of theatre lighting design, etc. It is very much an artistic. Now, you can try to answer the questions given here. First, what is peak and ground row? Second, compare the lenses and the reflector of PZ spot and Fresnel spot. 3. What are the major similarities of all the spotlights? 4. How to focus the Fresnel lights and floodlights? 5. How do you define that the lighting designer should be more creative? Hope that you may go through the reference books for further reading. Creative Your Own Stage Lighting by Tim Strader and John Williams, ISBN 071352569X, printed by Pernell and Sons Limited, Polton. Second, Stage Lighting explained by Neil Fraser, Crowwood Press, ISBN 1-86126-4909. Thank you for watching this program. We can meet again with another topic soon. Have a nice day.